Hello, everyone. Hope everyone is doing well and staying happy and cheerful. Uh, as you can see, I'm recording this lecture a lot later than the usual recording time. That's because I was busy going through the final project and making sure everything looked perfect. I hope all of you are having a good time going through the final project and getting a good recap of all the programming concepts that you have studied throughout this semester as part of 220. All right, let's talk about today's lecture. So, today's lecture is going to be the penultimate lecture on the topic of plotting, and also my penultimate lecture because Mike is going to be recording the Friday's lecture on randomness. That said, we are going to continue what we have been doing in the past with respect to plotting topics. We are going to be continuing writing a lot of code. So, like last lecture, I have a template notebook for you to download and follow this lecture through, which has a series of questions just like last time, based off a couple of examples. I don't know why it's taking so long to load. There we go. So you can actually get through the template and try to answer a few questions on your own by pausing this lecture video. All right. So my notebook for today's lecture is going to be the author notebook, which is again a copy of the template, but I'm going to actually fill it in. All right, so let's get started. I'm sure by now you would have gotten familiar with this cell's content. It's to make the Jupyter Notebook cell width wider and also set some of the text in the markdown cells to be highlighted by red and italic style as well. All right, so let's do a quick recap of the imports. So we are going to be using a lot of pandas when it comes to plotting. So we'll always have import statements to pandas, data frame, and series. And also recall that matplotlib enables you to configure a lot of parameters, including font size, which is like down here. And this command matplotlib inline enables you to display the plot generated inline within your notebook. So let's go ahead and do the imports and set the font size as well. All right. So the very first example that we are going to do today is something which is called as the stock market example, which I quite didn't get to start during last lecture. So I'm going to actually show you what is in the data set first. So I know that this is a CSV file. It's the SP500 CSV file, which stands for the stock details for the top 500 companies in the US. Pretty much like that covers 80% of the stocks, I guess. So you can get a good sense of like how the market variation is with by obtaining a view of this data set. So I'm just reading the CSV file using pandas read CSV function, read underscore CSV function, and I'm going to get a data frame out of pandas data frame out of this read function. I'm just doing the head function called to display the top 5 lines. So as you can see, there are indices for each rows, and then there are 2 columns which are year and return. So this particular data set starts with initial year as 1970. So what exactly is the return value? So after getting through the whole year of 1970, the return value talks about how much was your gain factor. So if your gain factor is 1, that means that you didn't get any loss or get any gain that particular year. Since in 1970 the return factor is a little bit higher than 1, that means that you did gain something. So how do you actually gain in stocks in general? There are 2 ways to do that. First one is that the stock price increases. As the year moves on, the value of the stock increases. And the second way to get gain is through dividends. So this is a combination of both of those actually to determine this factor. All right, so let's work through the very first question here. So the question asks, how do we compute total gain for every year. So let's think about this question here for a minute and consider an example. Let's say that you have $1,000 on your hand right now, and I'll tell you that it's going to double tomorrow. Then that means that you'll have $2,000 tomorrow, right? And then let's say for an example, it's going to triple the day after that. Then by triple, you don't do addition or something like that, right? You're going to again multiply by 3, and that's going to give you $6,000, right? So that's how you usually compute gain. So that's going to be the same that you apply to this column as well. So let's say that if you get started initially with $1,000 investment in 1970, then your return for the first year was like 1.04 some factor of 1,000. So that's going to be a little bit of gain above 1,000. What's going to be your gain in the next year is that you're going to be able to multiply that first year's return value by the next year's return value. And then similarly for 1972, it's going to be product of all these factors. That's because whenever your wealth multiplies, you think about cumulative product, right? So I'm going to introduce you to the function in pandas called CUMPROD, stands for cumulative product. So since we know what's there in the data frame, I'm just going to say take the return column and get me the cumulative product for the return column. And what do I want to do with it? I want to actually put it back into the data frame because I need to add a new column with it. So let me actually add a new column back into the data frame, and let me call it total. For example, total from the total gain here. And I did the computation. Let's do a peek as to what is the value here, right? Okay, so as I mentioned, the first year you're going to see the same value as the same total value as the return. The next year it's going to be a little bit higher because it's this number multiplied by this. And then if you keep going on like that, let's take a look at what happens at the end of 2018 in this particular data set. Your total is like increasing by a factor of almost 116, right? So that's a good thing. So that sort of like gives you some sense of like what sort of total gain that you can obtain for every year. Alright, moving on to the next question. The next question is asking, assuming you initially invested $1,000 in 1970, what is your total wealth in every future year? So clearly we need to define a variable for the initial investment. So I'm just going to call that as starting, and it says the starting value is $1,000. So we again need to compute the total wealth that you can gain in every future year, right? So if you get started with $1,000 initially, and let me do a df.dead head, not dead, sorry, head one more time. As you can see, you'll have like this factor of total gain for that particular year. You just need to multiply 1,000 by this factor to get the total gain for that particular year, right? So let's go ahead and do that. Once again, we are just going to multiply one of the data frame columns by some value, and this time instead of doing a cumulative multiplication using the function that we used before, we just want to multiply by the initial starting value. And then let me tag this as wealth column, and then let's take a peek at the data frame to see what's going on there. Alright, there you have it. So in 1970, your gain was like around $40. And as you can see, the stock market is not that stable, right? You sometimes might lose money instead of gaining money. Let's actually take a look at the last few rows here, because that's what is interesting, right? So you invested $1,000 in 1970, and somehow you saw through the investigation all these years, and lucky you've got a lot of wealth right now because of the initial small investment, right? So let's take a look at how do we create a line plot to look at the wealth gain over the years, right? So your wealth is a column in your data frame. Recall that each of the columns can be very easily plotted as lines using data frame dot plot dot line. So I'm going to say df dot plot dot line, and let's take a look at the initial plot over here. All right, so what do we have here? Sorry, I plotted the whole data frame instead of plotting just the wealth. So let me fix that. So I should say df of wealth dot plot dot line to just like plot the wealth. So as you can see, we initially got started with somewhere around $1,000, and then we ended up, very close to $100,000. Right? That's a lot of money. Lucky whoever the investor is. All right. So there are a few things that you could improve with respect to this plot, right? The x-axis just has indices from your data frame. Instead, we should have the year column. So the first thing that I'm going to do is I'm going to say df.setIndex to be the year column before I go ahead and extract the wealth column to do the plotting. That makes the plot a little bit better. And you also got the x-axis label over here. And let's go ahead and set the y-axis label. So recall that you can set axis label by retrieving the axis subplot object whenever you're creating a plot. So you can just say ax.set underscore y label, and here it's like your total wealth, and your wealth is in dollars, right? Let me go ahead and rerun the plot. There we go. So that's going to be your gain as multiple years of worth investment that you're going to get after how many years, like around 50 years, I guess, approximately. All right. So this has to do with like what has happened with the stock market in general. We are going to next try to understand like how can we project the risk factor when it comes to investing in the stock market going forward. So before that, I want to introduce to you what random simulation here is. So I'm going to go back up to the top of the notebook here, and I'm going to add a new import to a module called random. So Friday's lecture is going to cover a lot of details about randomness, but for now I'm going to just like briefly introduce to you the concept. So random module has a function called choice. So the choice function takes as an input a list. For example, let's say that I have as entry items in my list 3 integers, 3, 5 and 9. So what random is going to do is whenever you run your random.choice function call, you'll find that it randomly returns one of those values. So if you keep trying over and over again, you'll see that sometimes the values get repeated. So this is something which is called as sampling with replacement. So what do we mean by sampling with replacement is once one of those values is like given to you out as a sample whenever you're picking a choice, it gets replaced in the initial set of values, and somehow you can get the number 3 again, right? So let's actually try running it a couple of more times. So right now the value is 5. So if I run it again, it's 3. And then if I run it again, it's 5 again. So this exactly is what is meant by replacement. You're able to get the value 5 again. All right. So how do you actually draw multiple values? Because that's one of the main things that you would want to do when it comes to random sampling, right? You want to be able to have multiple trials. If you can recall this term from your probability lectures and whatever course that you studied probability in. All right. So I'm going to show you how to actually get multiple values. So the function for that is random dot choices. So what you need to give to random dot choices is you need to give the array of set of initial set of values from which you want to do the sampling, and you also want to pass a parameter called k, which is going to control how many samples that you want to generate, how many trials that you want to do when it comes to picking sample values. And a k value of 10 is going to return you 10 different choices. So if you keep running this function call over and over again, as you can see, you get a different set of lists every single time. All right, that's to do with the random simulation introduction part. Let's go back to the stock market example that we were discussing prior to this pause over here. And I was talking about considering this question where, like, how risky is it to invest in the stock market going forward? How do you actually answer this particular question? So the way that I'm going to show you with respect to an approach is sort of a two-step process. So the first step is going to be to run simulation and then randomly replay past years stock market increase or decrease factor, right? So that's going to be step one. So let me motivate as to why we need to run these simulations. So the stock market is highly unpredictable, right? So as an investor for a particular stock, you might be interested in knowing what are your risks when it comes to putting your money, let's say, for a 10-year period or a 20-year period. You'd want to analyze random samples from that particular stock's past history to come up with what is the best amount that you can invest and afford to not lose a lot of money as opposed to like gaining a lot more money, right? So that's why random simulations are very helpful when it comes to stock market analysis. That has to do with step one. Let me continue describing the approach. Step two is nothing but you were able to run some simulation in step one for some past years, right? Step two is going to be running hundreds of such simulations and exploring all such possible outcomes. So let me go ahead and first show you how we can write the code for step one. So I'm going to let me tag that as step one. I'm going to write a function called, let's call it run underscore sim for run simulation. And what do I need for this function is as parameters is I need like how many, sorry about that, I shouldn't have double clicked on that. Yes, how many years do we need to run the simulation for? So let me call that parameters as years, and I want to not hard code, set the default value as 10. And then what else do I need? I need the starting amount, right? And I'm going to set the default amount for that as $1,000. All right. Given that, we need to be able to use the random dot choices function, right? So the random dot choices function takes as an input a list. So what do we use from our data frame? Let me scroll back up. What we need for our data frame is this return column, right? That's what we need to give us the initial set of samples, so the initial set of values from which samples are chosen from. So what do we need to do? We need to call random dot choices, and that's gonna take an array over here, and then the second value is going to be how many how many trials that you want to do. So the trials are going to be the same as how many ever number of years that you want to pick. So after the first value is going to come from data frame of the column return, right? All right, so that has to do with the random dot choices function call. What does it return? It returns a list. So I'm just going to call that as random returns, and let's actually return random returns, and let's take a look at how this function is actually working. I'm going to make the function call within the next cell over here, but we'll look at the question later on. So first thing that we need to do is we need to be able to call run underscore sims, right? Sim, and I'm going to actually leave the parameters with the default values. Let's see what that returns. I forgot to run the above cell. There we go. All right. Let me actually, as you can see, it returns 10 different return values by random sampling. As you can see, every time it returns a different set of values, right? That's interesting. All right. So that has to do with part of step one. What is missing with step one is we want to be able to take into consideration this starting initial investment, right? So let's actually do one thing. Let's go ahead and convert this into a series before we return it. Because we will be using a series to do a lot of plots, it's very convenient to have it in the series format before we actually return the variable. So what do we need to do with the starting is we just need to multiply all the cumulative product of all these random return factors, and then we want to be able to multiply each of those cumulative products with the starting value, right? So I'm going to go ahead and save this back into random returns, or you could just like directly return it. So there we go, and then let's run this model again. All right, there we have it. So you have a bunch of gains, total gains that you can obtain by randomly selecting 10 different years, the gain factor or the loss factor, right? Okay. Now that we have completed step one, which enables you to run a simulation randomly replaying some past years, right? We were able to take the return column for some past years and then randomly compute what would be your total gain with those return values. So the next thing is going to be step two. Next step is going to be step two. Step two is nothing but you need to be able to run hundreds of such simulation, right? So I'm just like going to call this function as run n sims, and I'm going to say a parameter n for how many ever number of years that you need, how many ever number of repetitions that you want to run. And then you want again the parameters which need to go into run sim function call, right? So I'm going to say once again years, and the default value is 10, and then starting and the default value being 1000 over here. All right. What do we need to do inside this function is we want to be able to call the run sim function for how many ever number of times that is being passed as a parameter, right? So let me go ahead and copy paste this particular function call over here. So what do I need to do is I need to be able to call this n times. So I'm going to say write a for loop for I in range of n. Because I want a count sort of a loop, I'm going to use range function. And what do I need to do? I need to run the simulation every single time. That is, let me actually just go ahead and print it for now, and then we'll see what happens. And I'm going to replace my run sim function call with say run n sims and pass only the first n parameter, and I'm going to say that as 5 times. So as you can see, you have like 5 different set of total gains here. What we want is a neat way to be able to plot all of that, right? So I'm going to capture all of that into a data frame, and I'm going to call that data frame SIMS. That's because we have already used the variable df. I don't want to replace that with a local variable df and make it confusing. So I'm going to call that as sims, and let me initialize a new data frame. What do I need to do is instead of printing, I want each of those to become a column in my data frame, right? So I have my value already. So what do you have? What do you give here? Let's just say call it as sim and plus you know, your I value here to uniquely identify each column. And what do we need to do next? We need to return this data frame, right? So let me go ahead and return this data frame. And if I go ahead and run this code again, as you'll see, we have now a data frame where you have rows representing each of those years that you're interested in, and columns representing the simulation values. So let me actually go back here and probably like fix the initial data frame to we did a set index, but I didn't actually reassign that into another into the same data frame. I'm going to go back here and say df equal to df dot set index of year, so that we can actually actually this doesn't matter. Anyway, never mind. Since we are doing random choices, that doesn't really matter what we are talking about. Sorry about that. So let's go back to the example and what were we up to. So we have completed both the steps over here. The next question that we have in this notebook is, for 10 years, we want to be able to run 250 simulations, right? So how do we do that? So the number of repetitions for simulation is 250, and let me capture the data frame into a variable called sims, and I made a mistake by displaying the whole thing. Should have had sims.tail instead. So let me go ahead and stop that, hopefully. So I'll try to run it again. There we have it. Instead of displaying the whole data frame, which is going to be 10 rows of 250 columns, I just wanted to display the last 5 rows. Why did I display the last 5 rows? Is like the last 5 rows are more interesting because the cumulative gain or loss builds up over the years, right? So that's what we are going to visualize next. So as you can see, you have a huge data set, right? So this is going to make us go back to the philosophy of what it takes to becoming a successful data scientist. So I'm going to tell you one particular tip with respect to visualizing large data sets, is that you need to play both a detective role and a lawyer role. So I'm going to explain both of these roles with plotting as examples. So let's take a look at how to be a detective. So let's try to answer this question. How do we create a line plot to visualize all of the simulations? So that's quite simple, right? So it's just going to be, you have your simulations in the sims data frame. It's just going to be sims.plot.line, and recall that your sims data frame has 250 columns, and recall that line plot plots a line for one column, so that's gonna generate a plot with 250 lines in it. So let me see what's going on here. There we go. Finally. Okay. If you're thinking of the term ouch saying this, that would be a correct description of the reaction for this particular plot. As you can see, what is making it worse is this legend. So I'm going to reset the legend parameter to the plot line function call and set it to false. As you can see, this whole plot is so cluttered, right? So if you have a lot of time to poke around and you want to do a lot of analysis on your own and be a detective, such a plot might be useful. But think about presenting such a plot to your boss or to your whole organization, to your peers. They're going to have a head scratcher by looking at this plot, right? And they're going to go like, okay, wait, what's going on here? All right. So that's going to be part two of the role that you're going to play as a data scientist, which is like how to be a lawyer, which is going to be take the interesting parts of information from this plot and present it to other people. So what do I mean by interesting parts of this plot is that whenever it comes to analyzing a distribution, right? So you'll often hear the terms like mean, median, and something which is called as the percentile. So percentile is going to enable you to specify some percentile in your distribution and take out the values from that part of your distribution. So what percentile are we talking about when it comes to median? Is the 50th percentile is going to be median. So similarly, you can do a 95th percentile or 5th percentile or something like that. So that's going to be the lawyer hat that you're going to put on. So I'm going to show you how to do percentile computation. You're going to use a function which is called as quantile, which will enable you to compute percentiles. So I'm going to show you an example. So since we have the data frame in Sims, and I'm going to show you how to compute the median by using the quantile function call on the data frame. So you're going to have two different parameters for this function call. Let me actually introduce you to the first one. So the first one is going to be the percentile value that you're interested in picking, which is going to take a value between 0 and 1. So if you want to plot, if you want to get median values, you just need to specify 0.5. So what did that do? It actually gave you the median value in all the columns, right? That's going to be the default computation whenever it comes to the quantile function. Each of those simulations that useful if for you to actually get a median value? I don't think so, right? What's more interesting is why would you get a median value for 10 different random samples within one simulation? Instead, what you want to do is, given 1 year value, which is going to be represented by a row, what would be the median total gain or loss among all the simulations that you just did, right? So that's the more interesting question to answer. So you can control whether your quantile function takes the column or row for computation by passing a second parameter to this function called axis. So the default value for axis is 0. 0 is going to be column. So the value for row is going to be 1. 1 here, okay, and let me actually rerun this. So as you can see, that gives you a much better quantile computation. Alright, so let's say that you want to present this data to your boss, for instance. So what you want to do is you want to show, let's say, 5th percentile, median, and also the 95th percentile. Let's actually compute all three of that, and we are going to need to save the data somewhere, right? So we are going to be saving the 5th percentile. Let me see here. 5th is 0.05 and 50th is 0.5 and 95 is 0.95, and we want to be able to store all of this information. And once again, I'm going to prefer storing it in a data frame. So I'm going to create a brand new data frame. What do I need within the data frame? Within the data frame is that I think I'd go with the dictionary this time because I want to say what each of these values are. So there we go. Alright, so I'm going to create a brand new data frame and I want each of these values to become key value pairs in my dictionary, right? So I'm going to say fifth percentile value is this, and let me copy paste this whole thing so that I don't have to type over and over again. And this is going to be 50th percentile, and this is going to be 95th percentile, right? In fact, let me call it median. Nobody calls it as 50th percentile, actually. That's weird. All right. Now that we have created the data frame, let's actually take a look at the data frame. What's missing? The commas are missing in my dictionary that I created within my data frame. There we go. Just a quick recap. I had like 3 different values. So I created a dictionary of those values with key value pairs, and then I want to convert that dictionary into a data frame. That's what I'm doing in this particular cell. And there you go. You have a neat data frame with 3 different columns, each for 5th, median, and 95th percentile. Alright, visualizing this using line plots is very simple, right? You can just say plot dot line, and you can take a look at what's going on there. That's much better than the plot that you presented before, right? So you're going to say what's going to be the gain whenever you're plotting, let's see. Whenever you're plotting with the 5th percentile, median, and the 95th percentile, clearly the 95th percentile will give you a lot of gain, and whereas the median and the 5th percentile would give you the lowest possible gain, right? As you can see, there are a lot of ups and downs in this particular line. Alright, I'll actually let you guys figure out how to add more details to the plot, fixing the x-axis, y-axis, and legend, and so on. Alright, I'm going to move on to the next example here, which is going to be actually switching back to bar charts. So we are going to be actually using a real life data set on fire hydrants collected in Madison. So I'm going to show you what is there in the CSV file. Let me actually do a df.head first instead of doing df.columns. So as you can see, this particular CSV file has a lot of data and a lot of columns. There are like so many columns that you can't even actually see all the columns. So if you have a situation like that, you can use df.columns to list all possible columns that are there in your data frame, thereby enabling you to poke around your data set and learn more about it. Alright, we are going to be answering a couple of plot questions using this data set. So the first one is going to do with the fire hydrant colors. So as you would expect, this data set talks about the location of fire hydrants. You have like the x and y value, and then you have like things like, okay, what is the elevation and what's the manufacture and style, and there is also something which is called as color of the fire hydrant, given by nozzle color over here. So the first thing that we are going to do here is we are going to create a bar plot visualization of the nozzle color column. So let me actually show what is there in nozzle color column. There we go. Alright, so as you can see, I'm going to do a tail. You could see the head values here. As you can see, there are a bunch of values in the nozzle color column, right? So what we want to be able to do is we want to create a bar plot to visualize all of the colors, nozzle colors of fire hydrants. So what we need is we need a way to be able to sum how many blue fire hydrants are there, thereby forming one bar for the blue color, right? So for doing that, you can very easily use the dot, sorry, not dot, value underscore counts function, which is going to count each value in each unique value in the nozzle color column for you and give you a total count. So as you can see, there is a lot of redundancy when it comes to the naming of the colors, right? So it's time to do some cleanup. So how do you actually handle cleanup of the data here? So how to handle cleanup of the data? So you can just like use the string dot lower or upper function call to merge these different colors, right? So as you can see, real life data always has these sort of issues where you have to fix a lot of things and do a lot of cleanup before you can actually visualize the data. So the first thing that I'm going to show you is how to do cleanup. So I'm actually going to store this into a different data frame called clean underscore df. What do I want to clean up? I want to clean up all the colors and put all the colors into string dot upper, right? So give me a second. Let me actually move this line to a new code to a new line, and then I'll uncomment it later. So I want to be able to convert all of my color strings into upper or lower cases. And then what do I want to do after that is I want to get a value count of each of those colors again, right? There we go, much better, right? We eliminated all of those unnecessary duplicates. Alright, so what do we want to do now? We want to be able to create a bar plot visualization of all the colors representing the fire hydrants within Madison. So I can just recall that you can just like create a bar plot by saying let's see, clean underscore df dot plot dot bar, and let's see what happens there. Oh, what went wrong? Okay, sorry. It says empty data frame. Alright, I need to capture the value counts back into some other data frame, right? Or directly be able to plot that instead. So I'm going to move this comment up over here because that line had to do with cleanup. And I'm going to move the plotting part as part of the value counts function call itself. There we go, much better. Alright, one thing that you could do is you can play around with the colors over here, right? Recall that let's actually first of all set the y label for this example. Since this is a new example, I want to do that, and I'm going to capture the axis subplot into a variable called ax and say set y label, and the y label is going to be fire hydrant count, right? What are we going to do with the going back to what I was talking about, you can add fancy colors, right? These bars literally correspond to different color fire hydrants. So recall that your color parameter is given by color. And you could just say a single value to your color, let's say red, or you could make it fancy and pass a list of values, each corresponding to each of those colors. I'm going to go blue, green, orange is somehow not O. I don't remember what color is O actually. I'm just like typing this off my notes preparation for this class. So R is red, and then I'm assuming C is cyan because it's not quite clear what exactly C color is. So we can't really see white because of the white background, right? So I'm going to make white gray instead. There we go. We can't actually still see white because there is only one entry, whereas for the blue fire hydrant there are like 6,500 ones. The next time you come back to Madison, you should like go around and try to find some of these blue fire hydrants, because honestly I haven't found even one so far. I think all of the fire hydrants around campus are red in color. Even those around my home is also red in color. All right, so that's the first visualization that we are going to create. So the next visualization that we are going to create is another bar plot for the style column. So let me actually show you what is there in the style column. There we go. All right, so as you can see, you have like different styles of fire hydrants. What we want to be able to do is we want to be able to once again count all the values using the value underscore counts function, right? Sorry. Once again, I'm going to directly do the data cleanup by saying string.upper, and let's capture this into let's capture this into a variable called style counts. I'll tell you why I'm doing that. You'll know that in just a minute. And let's go ahead and do bar plot. All right, now you know why I captured that into a variable. That's a lot of bars to have within the same plot, right? So recall the trick that we used a couple of lectures ago. You can always create an other field and sum up all of this long tail whenever you have a long tail, right? So what is meant by a long tail is you have like initial high values and then your tail is like full of really small values. So whenever you have such a plot, you should think about summing up all of the information in the long tail and displaying an other bar plot instead. So that's what I'm going to do next. I'm going to leave this as such, and I'll do that in a new cell. So what we want to do is we want to be able to extract the initial set of columns. Let's say that we want to take a look at what's there in the first what's the count for first 12 columns. Let me do 13 and then we'll see. All right, so I'm just going to stop at first 12 over here. You can vary this however you want. So I'm going to keep my bar plot to have 12 bars for the first 12 styles, top 12 styles. And then the rest of the count is going to go into my other bar column, in my bar plot. So recall that you can just like save all of this data by using iLocation. So since we have let me use iLocation instead of saying just the slice value here. So the reason I'm doing that is I'm explicitly saying, okay, give me index location instead of the integer. I'm saying give me integer position location instead of giving me the index location. A little bit of fumble with the terms over there. As we have both, Mike and I have both mentioned, this is a weird naming that pandas people have with respect to calling a key index. All right, so what we want to do is we want to be able to extract just the first 12 counts, and I'm going to put it as let's say a variable called top 12. And what do I want next is I want to in my top 12 data frame, I want to create an other entry, and that other entry is going to be given by the rest of the data all summed up together, right? So I want everything from the 12th entry and I want to sum it all up. So let's take a look at what is there in top 12 before we actually plot it. There we go. So you have like all the row entries for the different top 12 styles, and then you have the other one. So you can very easily visualize this by saying a dot plot, sorry, what am I saying, top 12 dot plot dot bar, and say I want to give red color, for instance. There we go. Let's actually add a couple of axes here. So I need to save the axis subplot object. By now I'm sure like you should be very familiar with that. So I want to set x label to be um, hydrant, wait, um, yeah, hydrant count, because that's what x-axis is. And then I want to be able to set y label to, no, y label to hydrant count and x label to style, right? Sorry, I mixed that up. There we go. Okay. Recall that whenever it comes to having such a bar plot, you can consider switching that over to horizontal. So you can just say bar h, and you of course need to remember that you need to switch these values around. All right. So I'm going to wrap up today's lecture there, and we are going to actually continue this example as part of the next lecture as well, which is going to be the very last lecture that I am going to be recording. And then we'll try to answer this particular question as part of the last plotting lecture. All right. Have fun going through the final project.